5 is about the law of sines, and what we can use the law of sines for is to find angles and sides of a triangle. So you did this in geometry, so some of it should feel familiar to you. And then we're also going to learn a new way to find the area of triangles. Okay, do you guys remember how you usually find the area of triangles? Yeah, 1/2 base times height, so I'm going to talk about that as well. Okay, so the law of sines, you can use a triangle, and they give you the sine of A over A equals the sine of B over B, sine of C over C. But really, when you set up your equation, you're only going to use 2 at a time so that you can do what? Use 2 at a time so that you can, if you have 2 ratios equal to each other, what do you use to solve? Cross multiply, yep. So you multiply sine of A by B, and that's going to be equal to A times sine of B, and then you divide to find what you want, okay? So we're going to use 2 of these at a time. So the law of sines allows you to solve the triangle if you know either of the following. So the first case is if you know 2 angle measures. So 2 angle measures and any side length. Okay, so you need 2 angles and then 1 side. So the case that this would be, if we think back to geometry, is you could have, if you have 2 angle measures and any side length, you could have an angle side situation or an angle side angle situation. Do you guys remember those acronyms? Angle side, angle? Remember seeing them? Okay, so these were 2 similarity theorems that you used. So something, we'll just draw a little example. So if it's angle side, what that means is you have like this angle, and this side. If you have angle side angle, that means you have an angle, the side in between them, and then another angle. And this can be on any part of the triangle. That's why those are just 2 examples. Okay, so these would be things that you are given. Okay, the other thing that you could have is you could have 2 side lengths. Okay, so you could have 2 side lengths. And the measure of an angle that is not between them. So 2 side lengths and the measure of an angle that is not between them. Now this one is not a similarity theorem. Okay, this would be the side angle. Do you guys remember why that's not one of the similarity ones? See how it spells a naughty word backwards? Oh. And this is called the ambiguous case. Do you guys know what ambiguous means? That is kind of a big word. So ambiguous means it's not clear. Okay, so the ambiguous case, there's usually multiple scenarios there. And if you have a side angle, let's just draw a quick example of what that could look like. That means you could have this side, and this angle. Okay, and you can use the law of sines on that. So a lot of our directions today are going to say to solve each triangle. Now what that means when you are solving each triangle is you are finding all of the angles and all side lengths. So find all angles and sides. You have to find all of them. Okay, so for A, you are given the measure of angle D and the measure of angle F. So what you have to find for this one is the measure of angle E, okay, the side length of D, and the side length of E. Okay, so we have three different things that we want to find. Is there anything that you guys know right away which is going to be very simple to find? Yeah, well, which one, the side or the angle? Yeah, okay, why? Can you explain that?
Because triangles have to equal 1.
Yep. So all the angles have to equal 180, right? Okay, so if all the angles equal 180 to find the measure of angle E, all we have to do is take 180 and subtract 33 degrees and subtract 28 degrees. So if you have two angles, I would highly recommend that your first step is to find the missing angle. Okay, so you'll get 119 degrees. Okay, great. So we just found the first one on our list. Okay, and then if you guys want to draw it in your diagram, you can. You don't have to. Okay, and now we're actually going to use the law of sines. So when you use the law of sines, you need to have a matching pair. What that means is you need to have a side length and the angle across from it. So the only side length we're given in A is 15. What's the angle that's across from 15? 28. So we have to set up the sine of, and can you guys tell me whether it's the sine of 15 or 28? It's 28 because 28 is the angle measure. So when you're using sine, remember it's always of the angle here. Okay, so angle measures are always going to be paired with sine. So this is the sine of 28 over 15 equals, and it doesn't matter which one you find first. Usually I just go alphabetically, so for this one it would be the sine of 33, okay, over D. Alright, and then to solve, you are going to cross multiply. Okay, so if you're going to cross multiply, you multiply D by the sine of 28, so D times the sine of 28 degrees equals 15 times the sine of 33 degrees. Now, if you want D by itself, then we're going to divide both sides by the sine of 28. Okay, so then those will cancel. And this says we're going to round answers to the nearest tenth. How many places after the decimal is the nearest tenth? 1. Alright, so let's put this in our calculator. So 15 sine of 33 divided by the sine of 28. Okay, so if I'm rounding that to the nearest tenth, I'm going to get 17.4. Alright, so then the only thing left to find is E. So when you are finding E, okay, you want to use the one that you're given. This is a rounded answer, so I'm going to get a more exact answer if when I set this up, I do the sine of 28 over 15. And now I'm going to do equal to the sine of, and then what's across from E? What angle measures across from E? 119. So 119 degrees over E. Okay, and notice that I do want you to use your degree symbols for any time it's an angle measure. And really, you're going to get so good at doing the cross multiplying that you're going to be able to go right from here to saying that E is equal to 15 times the sine of 119 degrees divided by the sine of 28. Because you're multiplying these two together, right? And then you're dividing by sine of 28. One thing you do want to watch out for, if you are trying this in your calculator and you are not getting the same values that I am, one thing I want you to check is that you do close your parentheses when you are doing the sine of 119. The second thing is check your mode. So if we're using degrees as our input, what should our mode be in? Degrees. So let's check our mode, make sure we're in the right one. So mode, you should have degree selected. And then this is 27.9 for E. Okay, and then go ahead and start part B. Alright, so what did you guys find first for this one? Yeah, angle P. Okay, so we have to find measure of angle P, we have to find R, we have to find Q. Okay, now, once you find angle P, right, now you can use that when you're finding the others, because this is the only matching pair. Do you guys understand what I mean when I say it's a matching pair? It's the only side length given, so you have to have the angle across from it. So you had to find the measure of angle P first for this one. Okay, you could, because this one you have the matching pair, you didn't have to find this first. Okay, but this you absolutely do. Okay, so in both of your equations you should have the sine of 105 over 10, because that's your exact value. Okay. And it does not matter which one you find first, whether you find the R or the Q. And sometimes I'll even set up both my equations first. So check to make sure that your setups are correct. Okay, so I do need to see your setup, and then like I said, go ahead and you can jump right to here. 10 times sine of 36, and then it's divided by the sine of 105. Okay, and then we'll round that to the nearest tenth. For this one, 10 times the sine of 39 divided by the sine of 105. Okay, so I do want to see 1, 2, 3. Okay? Alright, what do we get for Q? 6.5. one is correct. And just need another minute for R. Are you ready? All right, what did you get? Great. Now, we can use our knowledge from geometry to make sure that these make sense. What is the biggest angle in the triangle? 105. So the longest side should be across from the largest angle. Is that happening here? Yeah, this side's 10. Both of these are lower than 10. And then do you see how these are pretty close together? Well, their angle measures are pretty close together, right? Okay, so that does make sense from what we know with geometry. Okay, largest side is across from the largest angle, smallest side across from the smallest angle. All right. Now, we're going to go to the next area where we can use the law of sines. And I'm going to let you know that your book says something different. I actually cut something out this year that I think is unnecessarily confusing, and it's honestly something that you don't need in your future math classes here. So this says solve each triangle, round your answers to the nearest tenth. I'm going to assign you some problems like this, but in the textbook, they're going to ask you to tell the number of triangles. So I just want you to write a little note. You do not need to find, okay, you do not need to find the number of triangles on your homework. You're going to just solve using the law of sines. Okay, so there, like we said earlier, there are some ambiguous cases. That ambiguous case means that sometimes, based on the information given, it could not be a triangle. It could be impossible to make a triangle with the values given. I just took those out. Okay? You could also have one triangle. That's what we're going to find. There are also ones where you could have two triangles. We're not going to do that. Okay? So you're just finding the one triangle. So you can ignore that part of the directions. We're just going to solve each triangle, round to the nearest tenth. Okay? All right, so we're going to solve each triangle, round to the nearest tenth. So they tell you in triangle ABC, A is 50, B is 20, the measure of A is 28. So I want you to just draw a sketch of ABC. It does not have to be to scale, okay? We just have to label A, B, C, and then we have to label them appropriately. So the capital A is going to be across from lowercase a. So if wherever your A is, you're just going to go across. That's going to be 50. Wherever your B is, go across. That's lowercase b. That's 20. Okay, and then this is lowercase c, which we don't have. And then the measure of A is 28 degrees, so that's going to be right here. Okay, so just like we did before, when we're solving the triangle, we want to find the values we don't have. So what we have to find here is angle B, the measure of angle B, the measure of angle C, and we have to find side C. How is this setup different than the ones we just did in example 1? Okay. Yes, we have to solve for the angles now. Before you were given 2 angles. Okay, now you're given 2 sides. So if we have to solve to find the angles, do you guys know what function we're going to use? Good, yeah, the inverses. Great. Okay, so let's set this up. So we have to find a matching pair. What's the only angle and side combination that we're given that we can use? So for example, we know that this B is 20, but we don't know what's across from it. We're given 28, we do have that across from it, so this is where we're going to start. The sine of 28 degrees over 50 equals, and then what we're going to do is we're going to use the B is 20, so the side length goes on the bottom, and then we're going to write sine of B on the top. The first time we do this, I'm going to write it out step by step, and then I'll let you know how we can proceed from there when you're doing your homework. So same as before, we're cross multiplying, right? So we do 50 times the sine of b, and we do 20 times the sine of 28 degrees. Okay. Also similar to what we did before, is we are going to divide both sides by 50. So we have the sine of b equals 20 times the sine of 28 degrees over 50. Okay, so the sine of b, how do I undo the sine from the angle b? I have to use the inverse, right? I can't divide it away. I have to use the inverse. So what we're going to be using in our calculator, and the next step that you're going to write is that the measure of angle B equals the sine inverse of 20 times the sine of 28 divided by 50. Okay, so there is a sign within the sine inverse. That's okay. So when you do the sine inverse to both sides, it undoes this, so all you're left with is b. And then let's go ahead and do our calculation. So we have the sine inverse first, so second sine button, and then 20 times the sine of 28, and then close your parentheses, okay, and then divide by 50. You don't have to close the last parentheses. Okay, so if we're rounding this to the nearest tenth, the measure of angle B is 10.8 degrees. So again, if you're not getting the same thing I am, first check your mode, then check your parentheses. Okay, do not round early. Do some of you like to do like the 20 sine of 28, like step by step, then divide by 50? You could do that, but when you do the sine inverse, you have to use the answer button. So you'd have to do second answer, okay, or else you're rounding too early. So if you like doing it step by step, you can, just you cannot round early, okay? All right, so now that you know that this is angle B, what should I find next? Yeah, angle C, okay? So now we know this is 10.8. So to find the measure of angle C, we can just do 180 minus 28 minus 10.8. Okay, so when you subtract, you should get 141.2 degrees. So earlier I said you don't have to, it's okay that your triangle isn't to scale, because obviously this isn't to scale. Okay, does that look like an obtuse angle? No. Okay, so this is more just helping us with the pairs. That's not what the actual triangle looks like. And based on this, if angle C is 141.2, when I find the side length C, what should it look like compared to the other sides? Should it be larger, bigger, about the same? Larger. Why? Yeah, angle C is the largest angle, so that should be the longest side. All right, so we're finding the side for this one. So now we know this is 141.2. So I'm going to do the sine of, again, keep this, the sine of 28 over 50. And the reason why you want to use this one is because, remember, this is a rounded value. Okay, so this is an exact value, so I'm going to use it to set up my equation. All right, and then this would be the sine of 141.2 over C. Now you only use the inverse if you're solving for an angle. So this is a side length, so because it is a side length, we're just going to cross multiply, so 50 times the sine of 141.2 degrees divided by the sine of 28. Okay, so go ahead and calculate that. parentheses do matter there. Okay, so did you guys get it at 66.7? Okay, and that is not a degree, that is a side length. Okay, so go ahead and set up the triangle for B. Set up the triangle for B. You can go ahead and check and make sure that your triangle was set up correctly. So across from 60 degrees should be that A is 9, and then you have B is 10. Okay, and then last class was talking about, oh, if it's 60 degrees, should they all be 60 degrees? They're all 60 degrees when it's what type of triangle? Equilateral, yes, okay. How do I know this is not an equilateral triangle? Yeah, the sides are different, okay. So these two sides are different, then they won't all be 60, so we do want to use this. So in both of your equations, let's use the sine of 60 over 9. Okay, and then what are we going to find next? What do I have to set that equal to? So this sine of 60, yeah, get it? Great. So I have to use this because B is the only other length I have. Okay, and then from here, if I cross multiply, it's perfectly fine if you skip here. The sine of B is 10 times the sine of 60 degrees divided by 9. And then angle B is the sine inverse of this entire equation, or expression technically. Alright, and then what do we get for the measure of angle B? Should use that time to do that part? Yep, great, 74.2 degrees. Do you guys like going back to some geometry things? Yeah. Can you guys guess what we're going to be doing tomorrow? You got it, law of cosines. And you didn't do law of cosines heavily in geometry, so I'm going to hit it a little harder this time. So 180 minus we've now found the 74.2. We are given the 60. So the measure of angle C equals 45.8 degrees. Alright, great. So now we have our two angle measures. We have to find side C. So when we set this up, like I said, use the one that's given, the sine of 60 over 9. That's the pair that's given. Okay, and then this will be the sine of 45.8 degrees divided by C. Now, when you're not finding an angle, do not use an inverse. Okay, the inverse is to find the angles only. Okay, and then we are just continuing to round this to the nearest 10. So what did we get for that one? Yeah, great. 7.5. All right, what questions do you guys have for me about log signs here? All right, the next thing we're going to talk about is a new way to find the area. So when you are finding the area of the triangle, you've been using 1/2 times base times height. Now for this triangle, why would that be a little more difficult to use 1/2 times base times height? Right, it's not a right triangle. There, you can't see the height easily. Where is the height in this triangle? Yeah, it would have to go like from the top here. Remember, the height always has this H to it, okay? So these are used to help you when you have a side angle side situation. Okay, so look here, you have B and C and the sine of A. So if you have B and C and A, you have side angle side. Okay, for A and C, sine is B. So you have side angle side. Here you have A and B, so side angle side. Okay, so these are equivalent equations. I'm actually going to talk to you about where they come from. So see how we drew this height here? This right triangle? Will you guys draw that with me? Okay, this triangle. So this is the height. I'm not going to label this as B because this is not the length of B, right? It's this entire thing that's B, but I am going to label this as my C, and this is going to be my A. So because it's a right triangle, I can use my sine, cosine, or tangent. So if I have angle A, and I have H and C, can you guys help me figure out what function I'm going to use? Why? Let's label. What is this? The opposite, adjacent, or hypotenuse? Okay, so this is the opposite. What is C in this case? The hypotenuse. Okay, so which one uses the opposite and the hypotenuse? Okay, so this would be the sine of what? Sine of A is equal to opposite H over C. Sorry, that's really minute. Okay, so what we did is the sine of A is the opposite over the hypotenuse, so H over C. Are you guys good with that? Okay, so let's solve this for the height. If I were to get the height by itself, what would I do to both sides? Yes, okay, so if I multiply both sides by C, okay, then what I have is that the height is equal to C times the sine of A. Okay, now let's look at an equation that has C times the sine of A. Which one of these has C times the sine of A in it? Let's look at the first equation. So the first equation says the area equals 1/2 times BC, and this is times the sine of A. So you guys see how that one has C times the sine of A in it? Okay, so I'll just say that one more time. So this is our equation. Area equals 1/2 BC sine of A, 1/2 BC sine of A, and then I boxed in C sine of A. Because what is C sine of A equal to? C sine of A is equal to H, the height, right? So what is this the same thing as? 1/2 times base times height. Oh my goodness, it's what we know and love. Okay, so yeah, it's the area of a triangle. Yay! Okay, so that's where it comes from. Okay? So what we have to do, now that we can use this awesome formula, is if we aren't given the height, as long as we have side angle side, we can just use this. Okay? So we have the side, the angle, and the side. Alright, so side angle side, you can label this whatever you want. But if we stick with our ABC, okay, then this 5 becomes B, this side is A, and then we have angle C. So which one uses angle C? Which one of these has angle C in it? 1, 2, or 3? 3. So the area is 1/2 times AB times the sine of C. Okay, so 1/2. My A is 3. My B is 5. This is 40 degrees. And then I just multiply. So 0.5. 3 times 5 is 15, so I'm just plugging in 15 times the sine of 40. Okay, and then we're just rounding that to the nearest tenth again. Nearest tenth. Today's all to the nearest tenth. Now, because it's the area and they give you the units, you're going to have to write the units what? Squared. So this is going to be meters squared. And yes, that's all you have to do. Okay, so once you label it, you are just going to plug it in, okay? All right, so for B, I want you to label this A, B, C, and angle B is 76 degrees. This side length is 13.6 feet. Side BC is 10.1 feet. Okay, and I want you to go ahead and find the area of this triangle. Alright, how are we feeling? How do we do? Okay, so you're given the C and the A and angle B. So your area is 1/2 A times C times the sine of B. So 1/2, 10.1 times 13.6 times the sine of 76 degrees. So what was your area? No, it's not. Good omen. Huh. So 66.6, and then don't forget your units, your feet squared, okay? All right, and then I'm going to give you some time to do your homework. Okay, so your homework is on page 727. So it's 10.5 to 2 through 5. And then you have some single problems. So just do number 11, number 13, 19 and 20, 24, and 29. Okay, so there's only 10 problems. I'm going to give you time right now.